Hello, everyone, and thank you for joining today's Code Long. My name is Risa, and I'm going to be your moderator today. We're going to kick off today's session in a couple of minutes. We're just going to wait so everyone has a chance to join. In the meanwhile, though, we'd love to hear from you. So let us know where you're joining from using the chat or the comments, depending on what platform you're watching on. And yeah, tell us something that you'd like to learn from today's session. If you have any questions in advance for our panelists today, JP, then let us know in the chat, and I'll be saving that for the Q&A as well. To note, we are going to be using DataCamp Workspace. I will be sharing a link so that you can code along with us shortly. So yeah, if you don't have a DataCamp Workspace account already, then please sign up for one now, and you should be able to code along with us. Also to note, today's session is being recorded, and the recording will be available for replay on whatever platform you're watching on. And for those that have actually registered on DataCamp, we will also be emailing you the recording as well. So make sure to register for the event. Head over to our LinkedIn, and you should be able to find the registration link. And yeah, we will send the recording over to you in the next few days. Hello, everyone, and thank you for joining today's Code Long. My name is Reese, and I'm going to be your moderator today. We're going to kick off today's session in about a minute or so. We're just waiting so everyone has a chance to join. Let us know where you're joining from using the chat and the comments, depending on what platform you're watching from. And yeah, tell us something that you'd like to learn in today's session. Just to note, we are using DataCamp Workspace for the session for the Code Along today. So if you don't have an account already, please sign up for one now. I've shared a link in the chat so you can code along with us. If you haven't seen it, I'll be posting it again shortly, and we'll also put a QR code up as well. So yeah, sign up for a DataCamp Workspace account if you don't already have one. This session is also being recorded, so you'll be able to rewatch it back on whatever stream platform you're watching on now, and we will also be emailing it to everyone that's registered for the event. If you haven't registered already, head over to our LinkedIn. You should be able to spot the event live there, and the registration link should be in there as well. So yeah, if you register for the event, we will send you all of our resources and goodies, as well as the recording in the next few days. Brilliant. I think that's everything from me. So now I'll hand you over to your host for today's session, Richie. Richie, please take it away.
Hi there, data scamps and data champs. This is Richie. Now, two of the most important use cases of generative AI that have emerged in the last few months are better chatbots and better website search. And in addition to the large language models, both of these use cases make use of a second technology, namely vector databases. And Weaviate is one of the most popular open source vector databases. And so today we're going to learn how to get started using it. Our guest is JP Huang. He's a technical curriculum coordinator at Weaviate. So JP creates educational content, helping the Weaviate community make better use of the platform, which is to say he's exactly the right person to teach you all today. So with that, over to you, JP.
Lovely. Thanks, Richie, and thanks, Reese and the team for having me. I'm really excited to be here. I'm really excited to meet your data campers, and I've used the platform quite a bit myself, and I'm really just happy to be, giving back and then meeting all of you here in person, well, person-ish. So today, what I'm going through is a bit of a workshop and code along, as you know, and we'll be doing it in the data camp workspace. What we'll do is, how do I share screens, Reese? Oh, fantastic. Got the screen up. So we'll be going through this notebook that I've pre-prepared. And now you'll be learning a few things along the way, right? What you'll see today is how to create a vector database with Weaviate. We'll be adding data to database. Of course, what would the database be without that? And how to interact with data. And that means performing some searches and also using large language models with your data without ever leaving Weaviate. So you'll see quite a bit of code. As much as that, though, what I would really love for you to take away from this is to learn what Weaviate is in terms of what a vector database is and the kinds of things it can do. And that means learning how it stores the data. And that means it's based on the meaning or the semantics of the data, which is where the vectors come in. And to the point, I would really love it if you looked at the content or the intent behind the syntax as much as the syntax itself, because there'll be a fair bit of new code, presumably for a lot of you. But of course, you can look those up yourself. But in that short period of time that we have, if you can get a good feel for what you can do with Weaviate, like semantic searches and different types of searches you can perform, and how it combines with large language models to transform your data. And I think that might change your perception of how databases work and how vector databases really manipulate your data more than just simply retrieve it as a data store. Cool. So with that said, there's a couple of things we'll do before we get on the way. As you'll see, what I've been doing is unhiding some of these cells as we move forward. And I've done that to kind of stop all these cells from distracting you as I go. And there's a couple other things I've done to prepare the session along the way. One of them is prepare an OpenAI API key. Now, I've saved this particular key as an environment variable in the workspace. And don't worry, what I'll do is as we get on the way, I'll paste a temporary key that we'll use, that you can use throughout this session. And if you're copying along, so if you're running along at home, following along later, you can get your own OpenAI key from the OpenAI website. I believe they have a free trial available from the website, so you can sign up, generate your own OpenAI key, and follow along there. In terms of right now, what we'll do is go along with the temporary key, so you can copy and paste that into your browser. Fantastic. So let's get underway. Now we're starting with essentially an empty Python environment because we're working in the DataCamp workspace. So what I'll do is I'll just pip install the Weaviate Python client. And you can do that from Jupyter by running this command with an exclamation mark, and you just pip install like you do on a regular shell. And I'll just execute the shell, and you get a fair few verbose commands. But in just a few seconds, we've got the Weaviate client installed. And of course, we'll get the data that we'll work with. We're going to be working with a subset of the Jeopardy quiz data set. Now, if you're maybe from the States or you've seen the TV show, it's a quiz show, and someone on Kaggle has kindly put together a data set of 200,000 plus questions from there. We won't quite necessarily work with that size data set here. We'll just work with a pre-processed version that I've got of just 1,000 rows. Of course, if you want to, you can copy that a lot, or you can use a larger data set later on. But for now, let's just download the data and go from there. I've just defined a couple of helper functions here for you to use. One just downloads the data from a GitHub repository. And in this particular case, I've got another function to load the data from my workspace because I've got that saved locally. So if you look in this files tab, I've got this JSON file of the data. So you should be able to see that, I think, in the workspace. Cool. So I'll just run that cell. This is pre-populated, so you should be able to just copy or just run that cell as is. So what I'm doing here is to just load the data, parsing that JSON, and we'll have a look at some of the contents of it. So that should just take a second or so. And we'll do a couple of things. One is to look at the type of the data. So it's a list. There's 1,000 rows or 1,000 items in the list. And hey, Reese, I'm getting a comment about some audio. Am I coming through?
Yeah, I'm hearing you fine.
We can hear you.
YouTube comment about audio. Maybe I'll bring my microphone a little bit closer. Sorry about that if you can't hear. So each row here is basically in a Python dictionary or a JSON object. So it's got a few bibliographical items about the quiz question. So when did it air on TV? What round was it? Blah, blah, as well as the question and the answer, which is really what the quiz is all about. Cool. So now that's the preparation and we can almost ready to get underway. So what I'll do is I'll just share the OpenAI key here. So you can just have that beforehand. So that's the key. And I'll just really clearly note that temporary key for live stream only. So if you want to use a key, you can use that one. Cool. So let's, we're going to be dealing with JSON responses quite a bit. So let's create a helper function just because I don't want to have to parse it in a particular way. So I'll just create a function called jprint. So it's a JSON print in, and all this is going to do is print a JSON dump, and you'll see what this is going to do fairly shortly. I think that should be right. Oh, I'm sorry. The first thing we'll want to do is to create a Weaviate database, right? So obviously we're going to be using a database. We have to create it somewhere. The easiest way that I use for teaching is to use what's called embedded Weaviate. This is a really quick way to create or spin up an instance of Weaviate. And look, there are other options for doing so as well. So I've listed a few different ones here. But to use embedded Weaviate, it's as simple as this. So we'll import the Weaviate library. And we'll instantiate a Weaviate client. Embedded options. So we'll provide a parameter called embedded options. And what we'll pass here is an instance of the embedded options class. And this is literally all you need to do to create an instance of Weaviate. So what that's going to do under the hood is to download Weaviate binary that's suitable for your system and spin that up. The only other optional thing that I'm going to do here is to pass an API key so we can use Weaviate. And what I'll do is to use additional headers. And as you'll see later, Weaviate is going to be contacting or using the OpenAI API, and we need the API key for that, which is what this key is for. So we'll have to pass that header with the name OpenAI API key. And let's use that one that I've got specified above, actually. That should work. Cool. And that should work. And you get quite a few messages, and that's just Weaviate spinning up in the background. And what you'll see is that that's created an instance of Weaviate just like that. But just to confirm that it's done that, we can confirm our jprint function that we've just defined. Client.is ready. Results of live coding. So it is ready, that's true, but that's not a JSON, so it's not going to do anything. And if I run the get meta method, what that's going to do is grab a whole lot of meta information about our Weaviate instance. So you see our host name, so that's how you connect to it if you're to connect it manually, and what Weaviate modules you're running. Now, this is a lot of detail. You don't need to know this at the time being, but it does tell us that our Weaviate instance is running and we're ready to go. Cool. So in just the last couple of minutes, we've spun up an instance of Weaviate. You've got your own Weaviate database that you can play with. Fantastic. Let's start by adding some data to it, right? The first thing we'll do is to create what's called a class definition. A lot of you are probably familiar with SQL or SQL. A class in Weaviate is the equivalent of an SQL table, or something that's called a collection in NoSQL databases. First thing we'll do is, depending on what you're doing, you might have some pre-populated data with the same table or class name. and when I run through these examples, I might have been doing the same thing a couple of times. So let's delete any data that I've already created. So what I'll do is I'll see client schema exists, and I'm going to create a bunch of questions. I'll call that class question. So if that class exists, client schema delete, class, need to wrap that in quotes. So all this is going to do is check if that class exists, and if it does, delete it. Just like deleting a table in SQL, this will delete all the data. So please do be mindful when you do run commands like this. And then next thing we'll do is create a new class definition. So what we'll do is create a class called question. We'll define a few things here. One is called a vectorizer. And this is going to be the Weaviate module that'll turn your data into vectors that represents meaning. We'll also define a generative module. This is the component of Weaviate that'll talk to a large language model so that you can transform your data before it comes back to you. This will mean a little bit more when we actually go through the exercise. And we'll also define some of the properties to save our quiz data onto. So you saw earlier that, let's go back. You saw earlier that our sample data that we looked at contained properties like what category does this quiz relate to, what's the question, and what's the answer, as well as some other bibliographical information. So we'll want to save as much of that as we want in the database. So we'll define the properties to do so. Here's a bit of a tip. So this is quite a bit of things to define. You can get example class definitions from our documentation. So let's have a look at that, because I think that'll be kind of instructive. So these are the sets of some example class configurations. I want to be using text objects and generative search here. So I'm actually just going to expand that section and just copy the code example. And let's go back to the workshop, or the workspace, excuse me. And what I'll do is say class definition equals all of this. So that's just the code example that I pasted from the documentation. So we'll change a few things. We'll call the class question, because again, that's what these relate to. And we can leave all of this stuff for the time being. We've now got a vectorizer that will contact OpenAI to generate vectors. And we've got the generative OpenAI module configured that'll use the large language model. We'll define these properties a little bit more though. So let's just ingest the question and answer. And this example relates to importing something like chunks of a book. So we'll just delete the rest of it. And because now we've got that dictionary defined, we are ready to create our class. And we can go to client, schema, create class definition. Now, I'm going through the syntax of it relatively quickly. And obviously, you're all new to Weaviate, and I've been using Weaviate for some time now. So this might seem like a lot of syntax that I'm rushing through. But as you saw in the example earlier, when I grabbed the class configuration, a lot of this is available verbatim in our documentation. So you can always look this up. And again, the kind of key takeaways that I would like you to leave with include more of the conceptual underpinnings around what's going on, more than the syntax, because the client syntax might change and so on over time. Cool. So here, again, we're creating a class, we're defining a class and creating it, just like how you might create a table in SQL. So let's do that. And we get some response back with some data. So did that work? Let's take a quick look. So now if I run this command, client schema.get, and put in our class name, we get a whole bunch of information back. We can use the jprint function again to format it. There we go. So it's nicely formatted as a JSON. And you can see that the class has the right name that we specified. And it'll have things like our module config that you saw parts of earlier, as well as our properties. But there's also a lot more information. And that's basically Weaviate using its defaults and sometimes inferring from what you specified to generate this class definition, because I'll get, being a vector database, there's a lot more that it needs to know about how to index the data before you goes ahead and does it. But again, for now, you don't need to know all the details of it, but all you need to know is that these are the properties that we've specifically provided. And with that, we were able to create a class. And because the class is created, or equivalent to a table in SQL, we can now import our data. Cool. Let's go ahead and do that. So before we actually do populate the data, let's just step through our objects and take a look at it. I actually can't remember what I've called it. So let's just remind ourselves what our data is called. I think it's just called data. Yeah. So our list is called data. So let's loop through. Let's call row in data. Let's build an object out of a couple of properties, right? So we'll say question is the question value for the key, and answer is row. We'll use the answer there. And to not flood our screen, we'll just get a couple of rows. Print data object. There you go. So we're able to now build a new dictionary called data object based on each row and print it out. So you can imagine if we loop through all of our 1,000 rows of data, we can manipulate it, right? So what we'll do next is use that information and add objects. So again, I'm going to be using a syntax very similar to what's shown in this how-to guide, but I'll just do it from memory, obviously. But you should be able to go to this website and copy and paste the syntax more or less verbatim. Cool. As batch. So we'll set up this context manager in Python, and that'll allow us to send groups of data as what's called batches, so that the internet lag or network latency, in more technical terms, would not be your bottleneck. And then what we can do is actually just copy and paste this whole section of code. We'll indent it because it's inside this context manager. I'll delete this. It loops through all of our rows. And now I can say, instead of printing out the individual row, add data object. And we just need to give it, the only properties you do need to provide are these. So we need to provide the data object, and which we built just above, right? And the class name, which here is question. So what that's going to do is to connect to Weaviate, use batches. It's going to loop through our data, build a data object, and add it to Weaviate using these batches. So let's see what happens. And in the meantime, what Weaviate's doing is contacting OpenAI, grabbing vectors for each object and populating it. So it's actually done that already for all 1,000 of our rows. And just to show that to you, I can create a new cell. And go just check the length of our list, and you can see there's 1,000 objects in there. So let's see if it actually did anything. So we'll actually run our first query with Weaviate. You can go client query. I always get this wrong. Aggregate. We'll look at the question class. Get meta count. Aggregate. Oh, it's with meta count. This syntax will aggregate objects from the question class and just give us a count back. So there you go. We've got 1,000 objects in Weaviate. Let's have a look at some actual objects in Weaviate. So for that, we'll look at the response. And the syntax gets a bit long, so I like to wrap it in brackets like so. We'll look at the question class. We'll get back the question and the answer properties that we've defined. So we're getting object from the question class, and we're asking for these properties back. We'll specify a limit just because we don't, again, want to grab all 1,000 objects back or even just very high number. And this is what we'll do. And the response is going to be a JSON format, which is not the easiest on the eye. So we'll use our jprint function. Cool, there we go. So we've got 3 objects back because we've specified our width limit 3. The first object is Adam, second one's Buffalo, and the third's Rock Band. And it looks like it's all coherent, it's in a similar format to what we specified, and so on. Now let's pause for a second, and I think this might be also a good time for you to, if you have any questions or comments about how we're going, the pace, and so on, please do feed them through, and perhaps Richie or Reese and I can have a chat about it. But also, I'll just quickly go through a little bit of a conceptual diagram of what I've done so far. This might look like quite a few pieces, but it's not necessarily so. So we've had our data, and we've sent requests to Weaviate through our batch import process. And you notice that's all we had. We didn't include a vector. And what Weaviate does in the background is it says, okay, that's fine, but I do need a vector from somewhere. And we've got a vectorizer module configured. So it asks for an object vector. And depending on what the vectorizer module is, it might look at, or it might contact an inference API, like the OpenAI API in this particular case, or a local model. And it gets the back-to-back, and that's how it builds the database. So in just the last 10, 15 minutes or so, we've created a Weaviate database. We've loaded up 1,000 rows of data. We've added them to Weaviate, including vectorizing it. So that's pretty cool. And you can do all these things with different tools, but using something like Weaviate really makes it fast, easy, and robust, and then scalable, as we'll see later. So yeah, I think that might be a natural time for a break.
All right, super. Thank you, JP. We've got 2 questions from the audience already. And for anyone else who wants to know anything else, wants to ask JP anything, then please do ask in the chat. Okay, so the first question is request, can you show the text for creating the client again?
Yeah.
Now, anyone who has missed any code, if you go to the files tab on the left, there is a solution workspace in there as well. So if you're missing anything, you can take a look at the solution. But for now, JP, do you want to just talk through what this code's doing again?
Yeah, absolutely. That's a really good question. And this particular code snippet is a little bit different to some of the other Weaviate examples you might see. So what we're using is something called embedded Weaviate. And what that does in the background is if you specify these parameters for that get instantiated here, is it downloads Weaviate from the internet and it runs it in the background on your machine. And this is all done from your client so that you don't have to go through the separate steps of spinning up a Docker container or creating it in on the cloud or anything like that. Now, there are reasons that you might want to do that. This is certainly not a production-ready solution or anything like that, but this is very convenient. So for the purposes of learning Weaviate, for the purpose of something like what I'm doing, which is demonstration, this is a really convenient option. If I might distract you a little bit with an alternative, you might have cases like this, and you'll see this later as well. If you want to connect to an existing Weaviate client, the syntax might look like this, right? So the Weaviate client, and you'll have, I think it's the URL, and you'll have the actual URL here, right? So one instance that I use all the time is edudemo, Weaviate, I think it's .network. So you might connect into something like that. And then you might provide authentication parameters in this kind of syntax. Or this might be if you're running your instance locally, it might be, oops. Or it might look something like this. But for now, we're using embedded Weaviate, and that kind of takes care of all that hard work, I suppose, of creating a database and waiting for it to spin up and all that. Oh, and sorry, and one more thing. This particular dictionary here that's passed on the additional headers is our OpenAI API key. So when Weaviate talks to OpenAI, it passes along this OpenAI key, which is your own key, and it uses that to generate vectors. I hope that was useful.
Yeah. So just related to this, I have a question for you. Can you explain when you would use each of those 4 options? So you mentioned that the embedded one is mainly for small data sets when you're sort of playing around and doing prototypes. When would you use the other 3 options?
Yeah, it's a really good question, and I'm trying to answer without being too verbose. But basically, it's a couple of things to consider. One is, are you using it for development or production, right? So if you're doing it for development or evaluation, I would use something like embedded. So if you're using it for development or evaluation, you would use embedded Weaviate or something like a sandbox on Weaviate Cloud Services, which is free. It's all kind of pre-configured for you. So you click a few buttons and it'll create a Weaviate instance. Now, if you want to go to the other end of the scale and use it in production, as for example, our clients do, you would use Kubernetes, right? So it's like containerized, it's scalable, and it's it's really easily scalable, right? In a cloud solution. There's something in between, like you can use something like Docker, which is cross-platform, so it does give you a little bit more flexibility. And the other benefit of using the Docker version is that you can customize it a lot more than some of the other options. So that's kind of where, so Docker's somewhere in the middle. It's perhaps not as easily scalable as using Kubernetes. So those are some of the considerations.
Okay, so you've got different options depending how much data you've got and how robust you need it to be.
100%, yeah, and how much time you want to spend, right? That's spinning up a Kubernetes cluster can be quite cumbersome. I'm not a DevOps guy, so it kind of baffles me a little bit from time to time too.
All right, so yeah, maybe leave the Kubernetes to people with some DevOps familiarity. All right, the next question comes from Michael, saying, "Oh, the steps between step 1 are empty, showing only Python." So actually, for this, Michael, if you joined late, basically we've been filling in the cells as we go. If you want to see what you've missed out on, click on Files on the left-hand side, and you should be able to see the solutions. It's called Notebook Example. That's got the code that you are missing in there. All right, and next question comes from Yukian, saying, when you talked about cosine, does that mean cosine similarity? So maybe do you want to talk through what cosine similarity is as well for people?
Yeah, that's a really good question, actually. So we'll see examples of vector search later. We'll see different types of searches later, one of which is vector search. And that's the whole reason behind using things like OpenAI and vectorizing our data. The way the distance between these vector objects are measured, you can measure them in a few different ways. And it's model dependent. So a model, when you train it, is trained on particular distance metrics. So you kind of need to tell it to evaluate those distance using the same metric. So in this particular case, because the OpenAI ADA model uses cosine distance, that's the distance metric we're using. So with Weaviate, you can specify things like dot distances, Euclidean, and so on. But yeah, you're exactly right. Cosine is cosine distance, and where it's used is in evaluating distance between the input vector and the outputs. And it's used in building the index as well, which we probably don't have time to get into. But you can think of it as in the same way that SQL databases build inverted index to speed up search, vector databases build vector indexes to speed up vector search.
All right, so just to make sure I've understood this correctly, you start off with a text string, and then you do it embedding, and that turns it into a numeric vector. And then when you have lots of these different text strings that have been turned into numeric vectors, you want to compare the distance between 2 different numeric vectors to work out like how closely related are these pieces of text. and then the cosine similarity is just like a score for how close those things are. Is that right?
Yeah, that's 100% correct. Yeah, and when we do vector search later, I can show the distance results in the search results. But yeah, the cosine distance is a way of calculating how similar or how far apart two objects are in quote unquote vector space.
All right, super. Okay, with that, I think we'll carry on, move on to the next section.
Lovely. Thank you very much. Cool. And then thanks for these questions too. They're really interesting, and I just love having the live audience as well. It's so much nicer to get live feedback and questions as we go. So please keep them coming. Okay. Let's now that we've seen a couple other queries, let's try sort of dig into the data a little bit more. Now, if you've used SQL, as I think many of you probably have, is you're probably used to or you've seen where clauses in SQL queries. So we'll start there. In Weaviate, we call them filtering, and we'll see why, because you sometimes might think of them as searching. So let's find objects that meet a particular condition. What we'll do is I won't start from scratch, so you can see what differences there are between these queries. Let's start with the same query that we had before. But what we'll do is we'll add a filter. Right, so I'll define a filter, which will be a dictionary. And again, don't worry too much about the syntax, because A, you can look them up, and B, they might change over time. But what we'll do is we'll tell Weaviate where to look. In this particular case, let's look in the answers, and we'll tell it what kind of operation to perform, and that'll be, let's look for similar string matches. And what string are you looking for? Let's say history. And to this query that we had before, all I'm going to do is to add another clause called where, and we'll put our newly constructed filter dictionary in here. So let's take a look. And voila, we actually just get the one response back, and we looked in the answer column, and what we've got is a pun on a brief history of time, but because it's got that matching word history, we get this answer back. I hope that's pretty self-explanatory, especially if you've used SQL before. So that's what's called a filter. And we can also use multiple filters, and you can imagine you can combine Boolean conditions. And that looks exactly like how you might imagine it looks. So in that particular case, our operator might be something like and here we'll do something like an operand. What that's going to do is now I can have one operator where, and that this is the exact same filter that we just used. So this is going to use, this is going to search to the answer column for an object matching history. Actually, let's use the or filter. And what I can do is to copy and paste that. And instead of the answer property, we'll use the question property. And now because we've got the, and the query syntax here doesn't change at all, we've just redefined our filter. And let's see if I've made any typos. Looks like I've done okay. Fantastic. So we've got results on the Field Museum, where the word history appears, excuse me, I don't know why that's jumping around. The word history appears in the question, and the same thing with these three rows. So that's a filter. And if I unhide that, it's a bit of an explanation. The thing with filters, though, it doesn't rank the results in any kind of meaningful way. In Weaviate, that's called a search, and you kind of start to see why we distinguish between the two here. So let's have a look at a keyword search. So unlike a keyword filter, and in the filter, we've just said, hey, look for objects that match these criteria. But nowhere in this query do we tell Weaviate to order the results in any particular way. So that's what a keyword search is going to do. In terms of the syntax, I'll just copy this query again. Let's go from there. In terms of the actual syntax, we'll just replace the with where argument, not quite a method, with bm25. And we'll just specify a word, and the actual keyword, if you want the argument, is query. So let's have a look at that and what that gets us. And it's done a similar thing, but you'll see that the order is different to what we had before. And without going into the maths and kind of like it can be quite dense and boring, what this keyword search does is to weight how significant the word history is in terms of how often it appears in the text versus how often you kind of expect it to appear in quote unquote normal text. So there's a fairly complex formula that's involved in deriving this, but basically at an intuitive level, if you think of it as this is weighing how important the word history is in the text, that's what it's doing. And now we get to the meat of vector databases, which is semantic search. Now, a semantic search searches objects based on their similarity. And this relates to our conversation with Richie about how a vector distance is being measured and what does that even actually mean. So hopefully we can run that query and that'll start to make a little bit more sense. So I'm going to replace this with bm25 with near text. And you can see with all these IntelliSense completions that there are a few different options. So these are different queries, so you can get objects back based on their similarity to an input, whether it's an object, text, or vector. And depending on what model you have, you might even be able to search objects based on how close it is to an input image, but we won't do that today. And what we'll do here is to search for a particular concept. Oops. And let's use the word history again just for consistency. What this is going to do is to search our list of objects based on how similar they are in concepts or meaning to the input history. So let's see what this does. We've got 3 results here. We've got an entry about the Greyhound Bus Company. We've got an entry about the Dutch National Art Museum, and we've got an entry about this Shinto religion texts. What you'll see missing that used to come up top is the Stephen Hawking entry. And I hope you can kind of see intuitively that it makes sense. While the word history is quite significant or prominent in this entry, this is not a historical entry, right? It's a very famous science book, but it's not necessarily history adjacent. Whereas these objects that came up under our semantic search, like it's actually not just about the Greyhound Bus Company, it's about this museum that this bus company relates to. The second entry is an art museum, and it talks about actually Louis Bonaparte in 1808, again, historical event. And the entry about Shinto religion is over 1,300 years old. So very, very historically significant or close to the concept of history, which is what we've done in this search. And how this works is where the kind of vector search magic comes in. And I'm going to be admittedly a little bit hand-wavy today, just in the interest of time. But under the hood, this uses a vector search, which is a similarity search. It looks for objects that are most similar to an input. This is a text input in this case, but as I mentioned before, we could, for example, look for an object that was similar to another object and so on. And we can actually inspect the questions earlier about distances and so on, how similar the result is. So to do that, we will add another argument with additional, and let's add this distance. It's amazing how when you do a live stream and your ability to type decreases by about 30%. There you go. Now we've got, as part of our output JSON object, distances. And these distances are the cosine distances between vectors. And what is a vector? Well, I can just quickly show you what a vector in this particular instance looks like, because each Weaviate object includes a vector. So I just replace that with additional with vector. And this is what a vector looks like. In case of OpenAI vectors, they are 1,500 so floating point numbers. So it's really uninteresting if you inspect them visually. But the analogy that I like to use, which I won't go through in detail here, is like this. If a lot of you probably have used Photoshop or MS Paint or something like that before, and you then would have seen color wheels or even 3D color boxes where you might specify colors in 3 numbers in like red, green, blue, RGB colors. And that's a form of a vector. You've got a concept or meaning of a color like red, like salmon, like or mauve or what have you. And you're representing the meaning of that in 3 numbers. Red, how red something is, how green something is, and how blue something is. Now, a vector that represents meaning of text is much, much longer, obviously, because meaning of text is a lot more nuanced and complex and rich. So we need larger sets of numbers and also a lot of granularity within those numbers, because RGB colors are represented as 8-bit integers, 16-bit integer, I think. But in terms of vectors for words, they're represented as something like between 300 to around 1,500 numbers, and they're all floating points, so they're kind of infinitely scalable within that range. And you can think of each of these numbers as dials that represent how, let's say, in a really vague sense, how big something is, how rich something is, how salty something is, or whatever. It doesn't quite map like that, but hopefully that kind of helps with the conception of what a vector is, in that they're just a very rich set of dials that you adjust to represent meaning. And this seems extremely hand wavy and black magic-y when you describe it like this. And just the fact that they work is extremely magical. And to be honest, what's really enabled this is deep learning models, because through the magic of machine learning or deep learning, they were able to come up with these vector representations that work. So these are called vector embeddings, and if you hear the words vector embedding thrown around, that's what this is. So I hope that was enough of a sort of high-level explanation to help you understand what's going on. And to be honest, to use vectors, you probably don't need to know a lot more than that. All you need to know in terms of using vectors is that they are, under the hood, a series of numbers. They come from machine learning models, and that they represent meaning. So that's kind of all you need to know in terms of end user of vector technology. Now that I've probably bored you a little bit for the last couple of minutes talking about fairly technical stuff, let's do something a little bit more interesting. This is, like, to be honest, my favorite bit. This is going through what's called generative search. So I won't show you those 1,000 numbers again in this session, so that's good. What I will do is use what's called generative search. And you'll remember I talked about large language models earlier on and also just now. And that's to show you what we can do with generative search, excuse me. So again, we've got the same search syntax as what you saw earlier. But what I'm going to do is to add this magic with generate command. And let's show you the single prompt example. And let's try an example where write a tweet with emojis emojis explaining the question and answer. So just keep in mind that, just note that this is not on f-string, where I'm populating this with a variable from somewhere else. This is a templated command to Weaviate. So Weaviate populates this question that's surrounded with braces with the actual question from each object, and the same thing with the answer. So let's see what we get. And then I'll talk through what's happened. This is a two-step process. So what Weaviate does is to perform this search, and the results from the search get sent to a large language model with this prompt, and it comes back. So let's see what it did. There you go. Here's one that talks about, it's promoting the bus company or Greyhound company and the museum around it. And this is remember, the original question and answer. And this next one does the same thing with the art museum. Again, you see the original answer and question, and so on. So what that's doing, again, is not just retrieving these results from Weaviate, but sending it to a large language model and transforming it before it even comes back to you. It's something different. I always like doing things like this. So translate this into French. Get rid of the there because it's a text. But there we go. I'm not going to attempt to read that, but you can see it's done an admirable job. And what's interesting is that these large language models are multilingual just because of the corpus that it's trained on, because they're not necessarily trained to do these things, or they're not trained with the purpose of being multilingual. But this particular language model, this is GPT 3.5, is multilingual, which is really cool. And the other thing I want to show you is this. So we've seen there's these three results that come back, and each result here has been transformed. Now, what I'm going to do here is what's called a group task. So in this case, we would retrieve results from Weaviate, and we're going to actually send them all together to Weaviate. We're going to retrieve results from Weaviate, and Weaviate is group those results together and send it to a large language model with a prompt. So we'll replace the single prompt argument with a group. I never remember what these parameters are called, group task. And let's say write a short poem about these facts. Fun one. And again, you should now get one result because the prompt has been grouped together into one lot. And let's see what it's done. So it's done something. You can see a bunch of line breaks, a new line, characters here. So instead of trying to parse that with the eye, which is not necessarily the easiest thing to do, let's create let's just type that out. So I think that was called response. Yeah. Response data, I think, get. So it's a bit of a nested dictionary, so it can be a little bit tricky. I think it's additional. It's generate grouped result. Yeah. So don't worry about this particular nest set of dictionary keys that I'm going through, but I'm just basically traversing through the dictionary keys because it's a nested dictionary, and then I kind of want to see that just the response from the large language model. And here we are. So that's the response. So in Hibbing, a town so grand, a bus company took its stand, Greyhound born in 1914, using hobmobiles, its history gleamed, and so on. It's quite a cute poem. It's amazing how well these things go. These things work, even though you give it three fairly unrelated inputs. And you can do a lot more with Weaviate. I won't spend a lot of time going through these, but here's another demo where I'm connecting to the education demo instance that I talked about earlier. And this is actually a read-only API key. So you can use this exact command, also this exact cell to connect to this instance and try your own queries. But I'll use that. So now I haven't imported OS. Okay. In this particular instance, I'm using my environmental variable or environment variable to get the API key. And that should now work. What I've got in there is a set of chunks from the book Pro Git, which is a really cool open source book on Git and GitHub. So I think it's called, oh gosh, so let me just see what I called that collection. I think it's Git book chunk. Yeah. I'll just, in the interest of time, I'll just run one query and stop. I've got a bunch of chunks from this book. So what I'll do is retrieve a few chunks related to, let's say, Git remote. Actually, no, that's the history of Git. And what I'm going to do is ask ChatGPT to, also GPT 3.5, to write a cute short story for children about this topic. So this is just to prove to you that I'm not feeding GPT with, I'm not telling GPT to write this story based on its pre-training, but what I'm doing is it's actually passing the data about the history of Git and saying, hey, write a story about this particular topic. Use emojis for cuteness. And we'll also copy this so that we can instantly look at the result. Oops, that is wrong. I need to replace that. So that's going to throw at the end of that query. And sometimes this takes a while, and that's just the response time from the large language model API. So what it's done is that query has actually worked, but because I had the old dictionary key in there for the question class, it's just thrown it with the last print command. So I'll just run this, and that's now worked because the response object has come back with the right data. It's just that I hadn't replaced the key there. So yeah, there we go. This is the response I've got. It's done exactly what we asked it to do, to write a children's story about the topic. In this particular case, this is about the history of Git, because I've asked Weaviate to retrieve chunks from the text about the history of Git. And, you know, it's given that it's probably not the most exciting children's book topic, it's done a pretty cute job. I think the last time I ran this, the story was about a character called Linux rather than the land called Linux and so on. But it's done a pretty good, admirable, I think, job of that. So quite a lot of time, what some of the demo apps people like to build with something like Weaviate is talk to, let's say a book like this, or I've built apps where I talk to YouTube videos in case, especially when they're quite long and I kind of want some assistance understanding what's going on there, because it's hard to consume all the content that's out there and so on. So yeah, there's a lot of things you can do with Weaviate. I hope this has helped you, scratch the surface of things you can do with it and vector search. And yeah, I'd love to hear what you think and what you build with tools like this. This is really cool. So yeah, that's it from me, guys. And Richie and Reese, I guess back to you, perhaps.
All right, super. So we've got a few questions from the audience. Lots of great questions, actually, so we might run a little bit over time. For anyone who has a hard stop, please do catch up on the questions in the recording afterwards. Before we go to questions, I just want to say we've got some upcoming webinars and code along. So tomorrow we've got a webinar on utilizing public data effectively. This is about how to make use of public free data sets. And then next Tuesday, we've got a code along on using AI to enhance product pages. So it's a little bit like this, this time we're using LangChain and Python and some generative AI. And then next Wednesday, there is a session on data science in the energy industry for people who are interested in a data career in that area. Okay, so next question from the audience comes from Edward saying, how do you specify other distance metrics or distance methods between vectors?
Yeah, it's an awesome question. So this is the example that you saw where we specified the distance here. So it's specified as a string. In terms of where to find other options in the documentation, in the references configuration, there's a distance metrics section. So you can go here and have a look. I should probably make that a little bit larger. And the available distance metrics and how they're defined and how they're used kind of in this table here. So that's how you would do it. And in terms of what distance metric to use when, you should really refer to the model documentation for whatever vectorizer you're using, right? So if you're using models from Hugging Face, in the model, I think card it's called on the Hugging Face documentation, it'll show what distance metric it's trained under and so on.
Excellent. So you got a choice of a few options there. By the way, in the chat, you should see a link to a feedback form. So JP, I believe you wanted some feedback. So for anyone in the audience, please do fill in that form and let JP know what you liked about the session. All right. So next question is another configuration type question. This comes from Ayan, I hope I'm pronouncing that correctly, saying, how do you specify which LLM to use when doing the generative search?
Yes, that's a really good one. In this particular case, I used generative OpenAI. In the, sorry, I'm just trying to search through. Okay, in the class definition, I specified here generative OpenAI as the module to use. So you have to do two things. One is to three things. One is to make sure that the module is available in your Weaviate, right? Because in some configurations, you can turn them on and off. And then you have to specify the module because I'm using an OpenAI. I'm using OpenAI, so I'm specifying the OpenAI related module here. And if I want to specify the model, there's additional parameters I can specify here to say I want to use GPT-4 and whatever the version of GPT-4 is with the larger context window and so on. So if I wanted to use a model from our friends at Cohere, I would specify this module, that the generative Cohere module, and specify model parameters as required. Again, in our documentation, we have a list of modules available under references and under readers and generators. I'll just make this larger again. So under our references modules, we have our readers and generators module. We have these generative modules. So we support ones from OpenAI, Cohere, Google Palm, and we've got more coming as well. So that's where you do that in terms of specifying what model to use.
All right, so you got a choice of a lot of the popular ones. All right, next question comes from Mohammed saying, how does Weaviate compare to other vector databases?
This is when I give the totally unbiased opinion about other vector databases. So obviously, I'm slightly biased. I think I'll talk about some of the things that I think we do well, right? Because to be honest, I'm probably I'm more knowledgeable about our product than our competitor products for sure. I think people like the fact that we are open source because some of our competitors are not. And that's kind of gives them assurance about what's under the hood and what's going on and the fact that they can contribute, and we prioritize based on our community wants as well. I think some of the other things that we do well is that we scale really well in production we did a demo last year or early this year with 1 billion objects in our data store. and that work just fine, which is, quite impressive. And there's a little bit of a difference between a vector database and what might be called vector indexes. So Weaviate, vector databases like Weaviate actually store the data itself and index the data based on the vectors, as well as using a traditional index. And that allows you to use Weaviate as your primary data store, whereas a vector index just is more of a secondary index just for using vector searches, but then you have to have another database to look up the actual object and retrieve the data from it once you've done your similarity search. So those are some of the key differentiators between us and some of our kind of competitors in this space.
All right, super. Before we finish, I actually have a question for you. So it seemed like a lot of the code here, it involved JSON, which has like very sort of nested data structures. What sort of skills do you need to know to work with this sort of JSON data?
Yeah, so I'll give two answers to that. One is that I'm sorry about the nested JSONs, and that's something that we are working on improving from a developer experience, user experience perspective, of using a lot of these untyped dictionaries, and nested JSONs is probably not the most user friendly thing. So we're actually like actively working on improving that experience, and that was one of the reasons I mentioned, hey, I would really love for the takeaway here to be not just the syntax, because that's something you can look up and copy and paste, right? But what's really important in this day and age, especially with tools like ChatGPT and Weaviate, is understanding what's going on under the hood and having really clear idea of what you want to build and how you want to build it. So that's one. In terms of working with JSONs, I think they look scarier than they are, right? Because once you have the response object back, and then you look at it and you're like, what is going on? But it's, in Python terms, it's kind of just nested dictionaries. Do you know what I mean? At the end of the day. So I think it takes a little bit of patience and a little bit of kind of getting used to the structure of the response. And that's one of the reasons I, do fairly silly things like define my own print function so it can have the indentation when you print it out, because it's the exact same data. All I've done is just clean it up a little bit, but it's, the cognitive like load when you look at it is so much lower when you have the right indentation. And then at the end of the day, it's just dictionary, so it can, like, I mean, I'm quite used to it now, but it's just like constantly do, whatever object dot keys to try and remind myself what the keys are called in the dictionary. So it's yeah, I think it's intimidating when you watch people like me do live streams with a product that they use day in, day out. But just take your time and work through it step by step is my advice.
All right, super. Yeah, I think the nested JSON sort of format is something that web developers love and maybe data scientists don't love quite as much. So that's interesting to know that it's changing. All right, final question before we go. So you said that it's important to understand like what you can actually build with these things. So can you just talk us through like what do businesses build using this sort of stuff?
Oh gosh, that's a really good question. I think it's, for a lot of people, it used to be search, right? You have masses of data and being able to do semantic searches, through whatever, like customer reviews, let's say, is a fairly typical example, right? Of I've got 100 million reviews. How do I find similar reviews? How do I categorize them, and so on? I think what's happening now is that there's kind of this drive towards retrieval augmented generation, which is one of the reasons we show generative search. And look, my toy examples of generating kids' stories or translating a sentence might not be transformative. But the fact that you can now not just retrieve data as it is, but you can transform it before it even gets to you is, I think, going to change a lot of businesses. So you don't have to just retrieve 40 reports, right, from a database and then redraw. Now you can say, actually, I'm going to retrieve those 40 reports, summarize them all, right, and then just get the summaries. And then that saves you so much in terms of just person hours. And the fact that you can have these tools at your disposal without ever leaving the database in this one integrated tool, I think is going to be quite transformative.
All right, super. That's really good to know, and it sounds like retrieval augmented generation might be something we have to do in a follow-up session. All right, super. Thank you so much for your time, JP. That was really, really cool, very informative. Thank you to Reese for moderating. Thank you to everyone who asked a question. Thank you to everyone who showed up today. I hope to see you in future webinars. Please do go to datacamp.com/webinars and sign up for more sessions. See you all again soon. Bye.
Thanks for having me.